projects. I've seen old projects getting rebuilt, getting made from scratch. I've seen a lot of problems that come with that. And at LSQI, we have a 20-year-old code base. So when I started working here 4 years ago, I was quite shocked that the first commit was from 2004. But it's really cool how we have maintained this application for so long. And over the years, I feel like I gained a lot of experience and knowledge and insights about how we deal with such an old code base in contrast to how I've seen other applications just be rebuilt from scratch, or even things like syncing two databases next to each other, or building an API layer for the old application. And I'd like to talk about just the pros and cons and how we do things and how that might be a good approach for code bases that you deal with as well. So yeah, that's what I hope to teach you. I'm going to talk about legacy code. What does it mean? And could we think about this in another way? Do we redefine it? And I'm going to talk about how we maintain long-lived code and how to develop for long-lived code. And I feel like these are two different approaches. So I'm going to get into that, and hopefully you can take away something from this. So what is a legacy code base? The picture on the left is quite relevant because I feel like for some old applications, it's kind of like the pyramids. People are like, so how were they built? Why was it built this way? Was it aliens? What's going on here? It's kind of like a black box, or black pyramid, kind of a mystery. But there are reasons you just don't know because it's legacy. We don't have the knowledge anymore. So there's a lot of different definitions for legacy that are being used by developers, and most often it means old code of bad quality that was left behind by someone who either left or went to a different function or isn't coding anymore, and we don't really know what to do with this. It's just kind of a mess, and that's how we talk about it. But in other definitions, it sometimes means code written for an unsupported language or platform. So the application is still here, but the language is no longer active, being updated. The platform or the framework is completely out of date, but we still have this thing. So even if you could really actively develop for it, it's still legacy because it's from the past, right? Another definition is code that is not being maintained but cannot be replaced. So that means even if the language or platform is still active, we can't replace it, we don't have the knowledge, we don't maintain it, but we also can't really move it because it's like an essential pillar in our entire infrastructure. Another definition is code that is costly to maintain or code that's just very old. So these are not quite the same things, right? So when we're talking about legacy, do we actually mean the same thing? And this vagueness, sorry, I keep seeing these are really annoying. This vagueness often leads us kind of astray in our approach. And I've also seen the label heritage being used, which is just kind of a cool way of legacy. Like it's literally a synonym for legacy. So I feel like using that word might also not be as helpful. It just kind of means the same thing, like you inherited something old. So which is it? What does legacy mean? So I want to, for a certain use case, I want to rethink legacy as a label for your app. And I've included a picture of the Sagrada Familia. I'm not sure who is familiar with this ancient church. Well, it's not that ancient, but they've been building it for like 100 years. And I think it's a really kind of visual and technical metaphor for an app that started long ago, and they have these really old foundations, this old design, but we're still developing it. We're still working on it. And it's been going for a while forever. It's still not finished. It might be one of those building projects that lasts forever. But I feel like that's a really good visual metaphor for how some web applications are. So there's a couple of criteria where I'm like, you should maybe rethink the label legacy for your app. That's, is your app still alive? Does it have active users? Does it have active servers? Is it still getting new features? Is it still getting new bug fixes? And will your app continue to live? So are there no plans for replacement? Is there an intention to invest in maintenance? Is both development and business on board with, we want to keep this application and we want to move it forward? Then your app actually is long-lived. And I feel like that really shows that it's both a bit old, it's been around a long time, but also lived as in it's alive, it's still here, we're just still doing something with it. And instead of legacy, let's call these kind of applications long lived, because I feel like that also motivates us more to invest in it more. So here comes my next argument. Why not rebuild from scratch? So I'm not sure who is familiar with this cartoon. It's been around for a while. I feel like I see this a lot where software engineers are really happy when they get to have a greenfields project. As you see in the cartoon, it's literally a greenfield. You've got all your tools. You're like, this time I'm going to do it right. Clean slate, solid foundations. This time we're going to do it the right way. And then 2 to 5 years down the line, you're like, oh no, we've done it again. So you see the house started out great, but then, business went this way. We had some other features. We had budget cuts or requirements, and then we had to do it this. And then before you know it, you once again have this mess, and you're like, well, let's rebuild things from scratch again. And you end up in this kind of cycle where you're also losing a lot of the value that you put into the application in the first place. So that would be my argument: is why not rebuild from scratch? Is there's a lot of domain knowledge in the application that you built, and that's very valuable. There's a lot of choices that were made by developers, by products, and you should hold on to that and not just replace it because the code structure has become messy. And it goes to like the past investment in time and money, in all the effort from the developers who went into that app. The other part is we don't know what we don't know. If you want to replace this application code because it's old and we don't really know what's in it, then replacing it is going to be a problem because we don't know what's in it. We think it's a mess. We want to replace it, and now we are going to miss the things that are in there that we didn't know about. So newer isn't necessarily better in that case. It could be because if, let's say, the business requirements change so much, or are just set up differently, it's like, no, we really want this new app, but then you do have to accept that you may lose the things that you are not thinking about in that instance that are in the app. And if you build a new application, it's also going to become long-lived. In a couple of years, you're going to end up with the same story, is that the app has grown in complexity, and if you didn't adapt your processes to deal with the maintenance, then you just have another messy app, right? So yeah, if those processes don't change, then every 5 years, let's say 5 to 10 years, the result is going to be the same. Are you going to rebuild the app in a new language, new framework every time and go through the same motions of, oh, what do you want to keep? What do you want to trash? You don't forget the parts that you may have invested in and no longer really looked at. So that would be my argument on maybe rebuilding from scratch isn't always the best idea. Of course, there are situations where it is a good idea, but I would like to propose to rethink this kind of approach. Like, it always has to be perfect new green fields, because there's a lot of pitfalls in that. Okay, let me take a sip of water. All right, off for a bit. There we go.
If we have questions, do you want us to save them for after the presentation, or can we just interrupt?
That's a good one. I think you can, I don't know if Google allows you to raise your hand. I think I see a hand icon. So that could be an option if you have a question, either raise your hand visually or on Google. And I'll try to answer it or indicate that I'm going to get into that later in the talk.
Yep.
All right. So let's start about, we've decided you don't want to rebuild from scratch. We have a long-lived app. How do we start maintaining it? And the first key phrase I would say is of maintenance is business value. There's a lot of talk about business value being in new features, delivering new stuff to users, but new features aren't built yet. They're just in a design phase, or maybe not even. Maybe they're just an idea that product or the management team has. So where is your value? Is in the existing application. So if you're not investing in maintenance of that application, then you're just letting your business value wither away and kind of sink into a slump of we don't know what's going on. So for these kind of applications, I feel like maintenance is really important, and it's where a lot of your business value actually is. And we need to start reevaluating long-lived applications in this way. Is that it's not just about building the newest, the shiniest, go go go, just build new, because then you get your whole messy situation. So how do you approach this process of maintaining long-lived code? And for that, I've come up with a way of categorizing tech debts, which I'll get into deeper in the next slide. An important one, of course, is keeping your dependencies up to date. I don't know who here is familiar with PHP and Symfony or Laravel. These are frameworks and languages that have a set update roadmap. So PHP will upgrade to a new minor version once a year. Symfony upgrades their minor version, I think, twice a year. So you can think ahead with that. So the kind of the libraries that also depend on those frameworks are not going to be up to date right away. So you're going to have to be behind a little bit when you're updating. But you can plan ahead. So you don't have to be caught off guard. Oh no, we have to do so much dependency work and it's really complicated and we have bugs and what's going on. You can plan ahead like a half year, a year, and be like, okay, that is the weeks or the month that we're gonna focus on our tech debts or our dependencies, and we really want to test things thoroughly and make sure we're all up to date. So at LSQI, the application is 20 years old, but we are currently on PHP 8.2. We're soon moving to 8.3, so we're very close to the newest version. We can probably do better, but that's also part of the process that we're trying to improve. But I feel like this is one of the things that's really important and has been really important in making sure your long-lived application doesn't sink into obscurity and unknown vagueness. Is to make sure it's up to date with modern libraries and dependencies that it's using. Another part of that is to put automated tooling in place. This is like just a big safety net. I think most devs are on board with static analysis, with automated testing, with unit testing. It just saves your skin, especially if you have a long-lived, complicated code base. You want to make sure that any change you make doesn't break your entire application. Was there a hand up? Am I seeing that right? No, sorry. Yeah, so these tools we've implemented over time and they've become really effective. It means that you have to worry less and just, I can have a whole separate talk about how important that is. I don't know if anyone is not on board with that, but raise the hands, let's go. All right, Remco, go ahead.
Yeah, I'm just wondering what do you use to keep your dependencies up to date or to keep track of that? Because in a 20-year-old application, I can imagine there are a lot of dependencies. If you have to check them manually, it's a lot of work.
Yeah, so in PHP there are some security advisories, so that's one way we keep up to date. But like I said, we also just try to go ahead with framework updates and PHP versions. And what you'll notice is all the libraries will kind of automatically age out because they're then using deprecated code. They have a way of calling functions or using classes in a way that's no longer supported by new language version. So that immediately raises a flag like, okay, this is something we need to look out for. And what often happens is we will try to upgrade, and then a library is no longer maintained or it's not updated as frequently. Then we really need to rethink, okay, what are we using it for? Do we want to do something else? Do we want to use another tool for this? So it comes down to just staying on top of it, scheduling the work that way, and rather than waiting for everything to blow up, just be like, okay, we want to keep things up to date. We want to be on this version. We don't want to be 2 or 3 major versions behind whatever libraries we use. And that's basically how we handle it. Yep. Does that answer your question?
Yeah, yeah. I also know that there are some automated tools. At least we use we use it when we do a git commit, for instance, to check for breached dependencies at least.
Yeah. And there is a tool called Rector in PHP, which automatically refactors your code to adhere to like the latest capabilities of a language. We don't actually use that tool because it also generates a lot of noise in commits. So we would frequently have commits that are like, oh, we all changed this to keep the code up to date. But it's also something we can discuss. So once in a while we'd be like, okay, we just really need to bring all of this up to date. We really need to add Titans everywhere. We really need to change the code style to do this. So it's also up for discussion, but we try to not use too much automated like fixing or refactoring tools because it introduces noise in the commits, and there's also a lot of value and historic knowledge in your commit history. So we do try to be aware of that.
Definitely, yeah.
All right, next to automated tooling, like I said, I kind of already went into that, to schedule maintenance work, which is part of the business value, so don't let it rely on there's one developer who's annoyed by the situation and they're going to tackle it like on the Friday afternoon or in their own spare time. It's part of the work that you're doing on the application, and it should be scheduled and planned that way, just in a sprint or on Kanban or whatever system of planning you use. It should just be part of the whole, just the whole process of working on this application. So let's get into the way that I've come up with to categorize tech debt, and maybe some of these terms or this way of thinking about things might be familiar to you. Basically what we have is we have two columns that are known scope and unknown scope, and two rows that are known code and unknown code. And depending on how long the tech has been there, how you're handling it, it falls into one of these categories, and you can really use this this quadrant to kind of get a grip on what tech that you have and how to approach it and how to kind of let it flow into your planning. So let's start with, known code, known scope. This is tech debt where we know where it is, we know what its impact is, we know how to change it, we've already done a lot of the research and talked about the design. Maybe we've written a proposal of this is a tech debt, this is how we want to change it, and these are the pitfalls, this is how we can assess it. We have this all prepared. So now all we need to do is actually schedule it as soon as possible. And it's very important that we schedule it as soon as possible, because as time goes on, we're going to lose our grip on things we research. There's going to be maybe code changes, there's going to be updates to libraries, and we're going to lose track of it again. So once we have all this information, its proposal on how to tackle this tech debt, we should also schedule it as soon as possible. So if we're talking sprints, then it should just be planned in a sprint. It should be, medium priority, and we need to get on that. The next category is known code, unknown scope. So this is tech debt that we know exists, but we haven't really done the research. We don't really know the full scope or the design of a refactor. It's likely that one or more developers will I know this is a mess and we need to do something with this, but we haven't really taken the time to dive into how we want to solve it. So the action would be to schedule research, maybe do some peer review, like let's look at this together, let's come up with ideas. We can also do some pair programming, some exploratory development, and once we know more, we can actually move this to known code, known scopes, and now we can actually plan the refactor. As you can see in the quadrant, there's basically 4 questions that we deal with depending on which category the tech debt is in. So we have, when do we solve this, or how are we going to solve this? Why did we lose track of this, and how can we find this? So for the next one, which is unknown code, known scope, that seems a bit of an odd one, right? But the thing is, we already put in a lot of time in the research, but then we lost track of it. We didn't give it enough priority to actually tackle it. It landed in a backlog somewhere. Then half a year to a year later, we find this issue, and we're like, either who wrote this, or why did we decide to do this, or it's no longer relevant because we're not using this feature, or we need to do something with this, but now we don't really know the process that landed us to this design in the first place. So what we need to do is, why did we lose track of it? So why didn't we prioritize it? And there could be very valid reasons for that. Like maybe, we're not using this feature, or maybe the approach we designed was way too complicated, or too costly, and business wasn't willing to invest in that. So we first need to analyze why we lost track of that, and then we also need to think, okay, we're going to take a fresh approach. If we still want to solve this tech debt, we can either throw out everything we did, or we can look at what we did and then take a fresh approach. Let's either bring in some new people who weren't involved, and ideally this will move to no code, no scope again, or no code and no scope. So we want to move out of this we don't know what's going on here phase. And the final one is the trickiest one to get a grip on. That's unknown code, unknown scope. And this is where the tech debt that just lives in the dark. It's there, but we don't know where it is or what it is or how big the impact is. And thankfully, there are ways of discovering this tech debt. The first one would be performance monitoring and testing. So seeing where a lot of slowdown in your app is happening. There's different ways of doing this. We can experiment, for example, with mutation testing to see where we are kind of having problems in our code. But there's also just looking at query, like slower queries, stuff like that. And there's a lot of tools available for that as well. The other thing is, if you keep having bugs in production, let's note down where in the code this is happening. Are these recent changes, or are these happening in parts of the code that we are not touching a lot, but we just keep fixing up? Instead of just bugs, as in things breaking, you could also look at how your users are handling it. So it's a part of the application that they're just really struggling with. That could also be kind of a tech debt smell. You can also, this is what happens a lot, if you're developing new features, you run into the tech debt. So that's a great time to note it down and either write some kind of proposal or at least make sure it will land somewhere in known code and known scope. So now we know there's a problem there and we can continue to tackle it. New hires are also really valuable in this because they enter your application, they look at your code base with a really fresh pair of eyes, and they will notice things that you no longer notice, especially developers and who've worked with code base for a long time that are no longer seeing the problems. So that's also really valuable. And there's also a process of code auditing. We've also recently done that, is have an external party look at our entire setup, look at our code base, and see where we potentially have problems or where we can invest more time and effort. And you can also do this internally, even by if you really want to kind of comb through the code, go class by class, function by function, and see, is this a problem or not? Of course, that's a very time-intensive approach, so that might not be your first solution. But if you really want to canvas it all out, that's also possible. Are there any questions so far?
I have one question. You say in known scope, known code, you schedule as soon as possible.
Yep.
But in my experience, I can always find like a mountain of tech debt, and I can feel like a whole year fixing tech debt. So what constitutes as soon as possible, in your opinion?
Yeah, so I feel like that process is very similar to new features. Let's say you find a tech debt, and then you do a lot of research, you write this proposal, this is how I want to change it, and then just like any other story, you kind of want to determine the priority, and maybe not even estimating story points, but that could also be helpful. That's something that we actually do. We're like, okay, this is going to be a project that's very big, then you want to break it down into smaller steps. One example is we recently changed all of our controllers to Symfony routing. This is a project that lasted over a year. So that's a big one that we had to track with a spreadsheet and everything. But it is something that at some point we were like, oh, you really need to invest more time. So we're going to focus on this for a month. So what I mean by schedule is it really needs to be a part of the planning, and you really need to look at what the priority is. And yeah, you can spend all year, of course, checking that, but then you also just need to look, okay, what's the biggest impact? What's going to solve the worst problems? What's going to take away the biggest pain points? And in that sense, it's just the same as feature development, is you want to solve this problem, and that factors into your scheduling. Does that answer your question?
Oh yes, thank you.
All right, cool. Patrick, you also had a question.
Yes, actually two questions. The first one is, how many different applications were you talking about right now? Because you were also talking about applications at your company. Is that one or more applications?
Yeah, we basically have one application, one big SaaS solution, and we've been working on that for a long time.
Do you use a specific framework or technology except PHP?
So it started out fully homebrew, and we've been slowly introducing more Symfony components, but we are not planning to completely change our stack to a Symfony framework or Symfony configuration. So we're really trying to integrate the components individually.
Okay. Yes. Thank you.
Yep. And I've also, worked with smaller applications or lots of greenfield apps, and yeah, it really depends on what you're working with. I imagine that if you have an application that was already built in a framework way from the start, maintenance could be easier, but it could also be harder because for us at least, we have to really think about every decision we make and how it relates to the bigger PHP ecosystem. All right, let me go on to the next slide. So this is going to be more about developing, so not maintenance, but how do we tackle new features, bug fixes, and basically I have a list of do's and don'ts. And do's, the first thing that I learned when working with this big application is surgical bug fixes, which rather than just making sweeping changes at everything that you're annoyed at as a developer, which is a lot for you dealing with along with codebase, is you really want to focus on what is the smallest change that will fix this bug and make that change, and then consider doing a regression test. It's not always possible, but ideally, once you have a bug where you're like, if I had an automated test for this, we would have caught it, then you write a regression test. And a regression test is exactly that, is you first write a test that fails because you didn't fix the bug, then you try to make the test pass. Once it passes, the bug should also be fixed. And that way you also gradually but certainly increase your test coverage across the application. We do sometimes make an exception. That's where their use case for the bug is so weird and specific, and it also dependent on strange customer data. We have an application with, I think, 140 different tenants. So they all have their own kind of specific data setup that might not always be the most common use case. But we do try to create automated tests once we have fixed bugs as well. The next step is to prevent new legacy with something called ADRs, architecture decision records. I don't know who here is familiar with that. It's something that I already touched when I went into categorizing tech debt. Basically, once you're in the process of defining the scope of solving your tech debt and your refactor, that is where you also write this ADR, which is basically we made these decisions about the architecture of this part of the code. This is why here are also the pitfalls, maybe even here's the reading we did on this. And what this does is once someone later on, even years ahead, goes back to why did they set this up this way, now you have the answers as to why. And that's really important for preventing new legacy. Because let's say all the developers involved with those changes leave or go work somewhere else, you still need that knowledge and you don't want it to be lost. And that's where ADRs really come in handy. So this is something we try to do once we have some bigger refactors, is to actually write out why we made the choices we did and how to keep that in mind. Ben, go ahead.
How do you manage those ADRs? Where do you store them and make sure that people actually read them? Because we also create a lot of documentation, but in practice we see that mainly developers forget to read them or forget to check the documentation?
Yeah, so for us, we do this in UTrack. So our commits will be tagged with issue number, or you can just use Jira or whatever issue tracker you use, and that will tell you exactly what the history is. So you go to that issue, and either it will be in the issue description itself, or it will be linked as an ADR tagged issue that says ADR, and then you can just look at it. So, because we found the same problem, like how do you keep track of that? And having it in the source code as a markdown file is just not very useful. No. Having it in, I think, what is it? Not Confluence. There's a knowledge base. that's also, people aren't going to look at that. So this is how we link it, and it has proven pretty successful, especially when we're looking at some kind of problem and we're like, okay, let's look at the commit. Okay, let's look at the issue number. We also see all the related stuff. It also links to the work that our product did. The product, like, writing the spec and writing the ideas. That's like a separate process. And it basically gives us the whole image of what happened here, and I feel like that's really valuable.
Yeah.
Does that answer your question?
Yes, thank you.
Okay, cool.
Okay.
The next step is, I kind of touched upon this with surgical bug fixes, is small incremental changes. No, Branko, go ahead.
Yeah, so I had another question about the ADR. So how do you decide at what size of a decision you make an ADR, or how many do you make? Or
Yeah, that's a very good question, and I think it's one of those classic answers. It depends. So it really depends on the size and complexity of the refactor. I think if it's like medium complexity or high complexity, that's when we do it. When it's like low effort changes or changes that are like very obvious. Let's say we want to add just a code style, but it is a refactor, right? Then it's like, well, we don't really need a decision. It makes sense because we want to be PSR something compliant, right? And that's already noted in the issue as well. So we do try to make U-track issues for everything, but not like a full ADR record for everything. And that, I think we just tend to do it on a case-by-case basis. But yeah, especially if it's like medium to high complexity and it's a lot of changes, and we definitely, like, let's say we're working on this for at least 2 weeks or longer, that's definitely a sign that we need to have an ADR. Does that answer your question?
yes, it does. Thank you.
It's very much it depends. Yeah, the next step would be small incremental changes. We used to like work with production and a develop branch, but we've been trying to work with trunk-based development, which is something that is described in the book Accelerate. I forgot who the authors are, which is basically you try to focus on making much smaller commits and making sure that you commit them directly to a production branch so that it can be rolled out. And what that does is it really forces you to think about, once again, the smallest change you can make that is effective without breaking everything. And it is challenging, but it's also really helped us to break down these bigger factors and reduce the number of bugs and merge conflicts and problems that happen once a big refactor is done. So rather than having a separate branch and then having like weeks of commits and trying to keep that up to date and then finally merging it and then having to test everything because there's problems in the merge or it conflicts with something, what we do is we use a lot of feature flags. So we will hide, let's say, a new feature from the customer by using a feature flag. This also allows our CSM, our customer success team, to test it before customers do, or first kind of release it to a few customers that are willing to test stuff. And this is how we kind of slowly roll out more complex changes. This is, for example, how we also changed all of our routes over the course of a year, just by going route by route rather than having these super long loop lines and then merging everything at once. So I feel like this approach really reduces the risk of having problems in production. And that kind of also ties into pacing, and this is a tricky one, I think, as developers who really want to go fast and make cool stuff and make it all work, and we really have to push ourselves to be slower, be deliberate, really think about what changes are we making, why are we making them. If we are unsure, just hit someone up on Slack, have a kind of pair programming session, really collaborate with things, and because, and this of course really depends on your situation, we're a SaaS company, so we have product, we're already selling it. There's not a lot of pressure to sell more. We can really invest time into the quality of our product. So this is what we try to do, is rather than worry about we really have to make all these changes now, it's like let's make slower quality changes. And AlsQI is a quality management system, so that's also a funny detail, is that quality is always on our minds. So that's one of the approaches we take as well, is to be slower and be more deliberate with our changes. The other part is just increasing test coverage by writing tests for new code, and I think that's a very common one. A lot of older code may not be well tested, but anything new you put out there should be properly tested, and that's one of the things that we try to do as well. Are there any other questions about this part? Nope. All right, let's continue. Then there's a list of don'ts, which is a lot of kind of hit phrases that go around in the tech industry, which is one of the biggest ones is Boy Scouting or Girl Scouting or Scouting, as I call it. I think this one's very popular because developers tend to kind of have a sense or feeling for things that aren't working the way they want, and they want to change it. But we found out more often than not, this creates a bug, this creates problems, especially in older code that isn't well tested. Or once again, you make changes, but you don't have the paper trail. So someone made changes, and now we don't know why, except I guess they were Boy Scouting. We don't know. So if there are these changes we want to make, we're like, okay, let's make an issue, let's discuss it. And yes, that does result in more slow, more, let's say, bureaucracy, but it's really prevented problems in production. The other one is, F around and find out. We try not to do that because we have a big app, we have a lot of customers, we cannot really afford to F around and find out. So we don't want to do that. I feel like this is, if you have a startup and you're working with like cutting edge technology and everything is new and fresh, this is a valid approach, but not for a long-lived code base for sure. And the other thing is fail forward fast. This is something we actually used to do, and it was, as developers, it is satisfying, because even if you fail, you roll it out again. We release to production twice a day, once for our European customers and once for our US customers. So we have 2 points a day that we can already roll things out. We can even hotfix if we want. But we just found out the hard way that our customers are not happy with things failing, even if we can fix them really fast. We just want to prevent things failing in the first place. So we really have to invest more time into testing, into quality beforehand, and rather than adopt this approach of just failing and going fast to fix it. So we really want to prevent the failure in the first place. The other don't is this kind of idea of being a 10x rockstar, ninja, hero, developer, like having this person who is, as you see in the picture, they're just in their dark room, and you give them a task and don't hear from them, and then they deliver this amazing product days or weeks later. This doesn't help, because then nobody else knows what happened or what choices were made or why. And even though they fix things really fast, they're kind of doing it outside of the process. So they're actually creating tech debt, even if the feature they delivered is really well done. In a couple of years, we're not going to know how or why, because they worked on an island and made choices that weren't documented. So we really kind of want to prevent this attitude of having this one really cool developer. I think it's also called like the bus problem, like if this person gets hit by a bus tomorrow and nobody knows what's going on with the code. So we really try to be more collaborative, to either share a lot of knowledge during the process or during design and refactor and writing the ADR, or we try to do it afterwards. Like, for example, I think last year, September, I made a big refactor in one part of code, and afterwards I wrote the ADR and I shared the knowledge. So I made a presentation about like, here's what I changed, this is why, this is how it works now. And that is really how we try to do the process, and make sure we involve everyone, both senior devs, junior devs, and make sure everyone's a part of the same story. The other thing not to do is to decrease test coverage. This sometimes happens when you remove a lot of tests, but ideally it shouldn't. So we do try to keep an eye on that, is that our test coverage shouldn't go down, it should go up. Test coverage can be kind of a false positive sometimes, because even high test coverage doesn't tell you that your tests are testing the right things. So it's something to keep in mind, but also not something to hold on to as a crutch. But yeah, we do try to not have a lot of decrease in test coverage. And finally, the big don't is don't play the blame game. As I said, we try to be constructive and collaborative, and not be like, okay, this bug happened, it's your fault, you fix it, or you need to do this because we think that it promotes kind of a really toxic situation where people kind of isolate themselves because they don't want to be blamed, or they feel less confident in making proposals or making good changes because they are afraid of things going wrong. So when there's a bug, when there's a crash, and there's a big problem, then we try to look at why did this happen? Can we solve this through pair programming? Can we solve this through better code reviews? Can we solve this through automated tooling? What happened here? And a big thing we recently did is we released a tool called Twig QI, which is a static analysis tool for Twig templates, which there wasn't really any. So that's interesting, is that there wasn't really any good tooling for that. So we've released kind of a tool that does it very quickly. It's more of a smoke test, I would say, than really in-depth analysis. But it's really prevented us from releasing bugs to production that we wouldn't have caught otherwise, especially during a refactor. And it happened because we had some big production crashes in things that we were like, hey, this Twig is PHP code eventually, so how do we catch this, right? Instead of being like, you made this change and it's your fault. So a big don't would be to stop. A don't is to really feed into this kind of blame and making people feel bad, because it's not going to help them write better code. All right, so in summary, so let's go back to what I went through at the start. Is what I want to teach is to redefine legacy to long live if your app is still alive and will continue to be, to have, rather than look at this legacy definition that's quite vague, let's redefine it and talk about our app as something that's been around for a long time and that we want to continue to invest in. Consider not starting from scratch if you have a big app and you are like, this is a mess and what do we do with it? Maintenance should be valued the same as new feature developments, both by devs and by business. And there's a lot of research in this as well that I don't have links for right now. But basically, investing in maintenance delivers just as much actual business value to end customers as it does new feature developments, because happy customers are going to be happier working with the app. They're going to be advocates for the app to other potential customers as well. So that's very important. And it also really prevents churn, so customers who leave because they're not happy with the app. Then there's treating maintenance like a normal part of your development process. So do refinement, do research, schedule it in your sprint or in your normal planning process, just like you would feature development, and develop with care and with consideration rather than going fast and blaming everyone and isolating yourself. So let's be more aware and more careful with development, and that is how we tackle our 20-year-old code base. That was it. Are there any questions?
Awesome, thank you. Yeah.
You can find me at, that's just my email address, subscribe, or Daniëlle Suurlant on GitHub.
I have a question about penultimate sheet. You contradict a lot of common wisdom, especially the sheet previous to this one. Especially, I'm interested in why you came to this opinion about Boy Scouting, and I think I tend to disagree, but maybe not. I mean, in my perception, Boy Scouting is mostly getting the codes up to par with what is already decided. Do you have a problem with that, or is it mostly people deciding on, or making new decisions on the way to factor the code?
I think it's a little bit of both. So sometimes it does happen that people will Boy Scout because they see a problem and they want to immediately fix it, and they kind of go around the process of, let's look at this problem, let's look at a way to fix it. So then you have changes that are not documented and that nobody really knows what happened there, and it's a problem because it also goes outside of the normal review process. So then you end up with a bug in production because someone decided to change the return types on 10 different classes because they were annoyed by this one thing. and then, oh, it's breaking, why? So it has this kind of like too loose approach. But when making changes that already been decided on, I'm not sure that is voice scouting, maybe it is, and then it should probably just be part of your maintenance process, right? So it's not voice scouting. It's like we decided to make these changes, we're going to schedule them, here you go make the changes. So that's kind of how I see it, is if it's been decided on, it should just be part of your planning process. And I know that it all sounds very bureaucratic, and it kind of is, because that's how you prevent a lot of crashes and a lot of problems when dealing with a big long list code base. Does that answer your question? Patrick, go ahead.
Yes, first of all, thank you for the presentation.
Yes.
I also have a question. It's about the last sheet, the summary sheet.
Yes.
I was wondering about the second point, consider not starting from scratch.
Yep.
Well, not right now, but maybe in 1 or 2 years, I would consider starting from scratch because of the technology we're currently using.
Yeah. Yeah, so that's an interesting one. I think it ties into, let me see, in these definitions. So is this language that's no longer supported, or the platform is no longer maintained? Then it might be a good idea to rebuild, because you can't really move forward with your app because the language or the framework is dead. So it's already kind of legacy. So that's not quite the same as the long lived, right? So it's still active, it's still getting new features and bug fixes. I think maybe I forgot to note the dependencies as well, so that's actually a good point. So I'll factor that into the presentation as well. Then there's this one, of course. You don't need to rebuild from scratch, but you can. But it really depends on your situation, right? So it's kind of like consider the pros and cons and don't always use it as the default.
What I'm considering right now is the framework. Of course, does get major updates, but it's very hard or close to impossible to get to the new update. It's very hard, but not so good documented, and it's a lot of effort. We're also missing some features. So at some point, I think that the amount of hours needed to migrate to the next version might be a consideration to change the framework at all.
Yeah, and I think that's one of the big challenges, right? Is that what we did is we had a code base that was completely homebrew, and we spent years just integrating newer components. And instead of throwing it all out and starting up from scratch with the framework way, is we spent all the effort doing it our way, and gradually the app became easier and easier to maintain. But that's also a multi-year effort. So it's one of those it depends kind of questions, and I feel like rebuilding it from scratch also comes with a lot of pitfalls. I've had a situation where I had to keep 2 databases in sync, or you have to use constant API calls to synchronize between the old and the new, or users might update. So it's one of those things where you maybe want to do like a pros and cons analysis. I think in Dutch it's like a kosten-baten-analyse. I forget what the English term is. So that's why my point is consider not building from scratch. It's not that you never have to do it, but it's also worthwhile. Let's say you do decide to build from scratch or start with a new framework. Then you might want to think about, okay, how do we prevent this from happening again? So how do we prevent this from in 5, 10 years having the same app that we now need to rebuild from scratch again? So rather than being in this cycle of we're going to do things the right way, oh no, we're here again. So that's also something to think about. So even if you do make the decision to rebuild from scratch.
Can I add something at this point?
Yep, go ahead.
I find it also an interesting sheet that you presented, the sheet you're currently showing. On the other way, I actually had a meeting today about this application. And they asked me the question, do you expect any progress in next year? And I said no. But so for the next year, I think everything is fine. But if you look further than 1 year from now, maybe I'm considering building from scratch. Maybe at some point I would give that recommendation. So it's a two-way street.
Yep. Yeah, and one thing you could do is maybe actually measure, like how much time are we spending trying to maintain this old system, and how much time would it take, and then look at how much time would it take to rebuild it from scratch. Because if the code base is 11 years old and there's 11 years of domain knowledge, of decisions, of development in there, how long would it take to rebuild it from scratch? Let's say, is that a year? Is that 3 years? And I think people really underestimate how long it takes to build software and build it right. So even if you do make a decision to rebuild, which could totally be the right decision, right? So I'm not saying you never should do that. It's still going to take a lot of time and effort, and you are going to have to change your process to make sure the same thing doesn't happen again. So that would be my recommendation, is consider it, but actually, I'd say approach it like a research project, right? So we have our hypothesis, we want to rebuild from scratch, what are the pros, what are the cons, what are we going to do, is this a good idea, is it not, and actually make a choice on the information that you have available. Because I feel like a lot of developers get frustrated building with, working with old code, so I definitely get that, I get that frustration, but there are different ways of tackling it. There is like a way out of the forest. Remco, go ahead.
Yeah,
Okay, thank you for your explanation.
I hope that answers your question, maybe not, because it all boils down to it depends. But yeah.
Thank you.
I'd like to react to that, if that's possible. I very, very strongly agree with you. I think people both underestimate how much work it is to rebuild, but also overestimate how much work it is to do a big migration. Because if you have some big migration, it's mostly very technical and not very domain knowledge. So it's easier to get outside help, it's easier to get resources. And at my last job, we actually even did a migration from a classic ASP application to a C# application. And a colleague of mine built his own compiler for that. And he spent months on it, but spending months is still way, way, way less than rebuilding an app which has been built for, at that point, I think 20 years or so.
So build a compiler to actually translate all your PHP code to C#, am I understanding that correctly?
Yeah, classic ASP code, but it's very similar to PHP. It's a VB script.
So even, wow.
And it compiled to very terrible C# code, but now you have C# code which can tidy up with C# tooling, which is way, way better.
That's interesting, because of course PHP compiles to, is it C or is it opcodes? I'm not sure. But yeah, that's actually really cool to compile it to a new language and start working from there, because C# is, that's just a very popular language. So yeah, it's, a lot of people, you know, it's really, really active. It's kind of like the, I would say, Microsoft version of Java, but better.
Yeah.
It's a lot stricter, at least. So that's fine now. I almost wanted to see C# development, almost. But yeah, that's a really cool solution, actually. And if that's a great example of, you didn't actually rebuild it from scratch. You recompiled it to a different language. Like, that's a third option I didn't even think about.
Yeah, you can also do that kind of stuff if you just migrate within frameworks or something like that. Maybe you don't have a full compiler, but just a search and replace. And it's hard, and it's a lot of work, but still less than rewriting. Yep.
Yeah, and that way you do actually keep your domain knowledge if you just go file by file, let's say class by class. And it's also an interesting process because you would run into tech debt during that process, and you can also even categorize it. So that's actually a valid kind of third use case, is you don't have to rebuild, you can also migrate in another way. So thank you for that suggestion, because I didn't really consider that. Patrick, go ahead.
What did you mean with migrate within framework? Is that the same framework or migrate to another framework in the same language? What did you mean?
Well, the best example I know is GitHub did that for upgrading their Rails framework. And they made like this preprocessor which processed the whole code base. And they had like this running pull request in which they kept their code base with some kind of processor which migrated the code to the new Rails, and then they just went and looked at all the failing tests and had to fix stuff in their existing code so it would go correctly through the migration. And the reason I think that stuff is interesting because it's an interesting problem to solve. To me, much more interesting than to rebuild an app, and you keep your app.
Yeah, it's a really cool one, actually. Yeah, I've been in a situation where I think in my previous employer there was like a board like, why is name of old app still alive? And 5 years later it was still there, or at least once I was there they were like, it's been there for years. I'm like, well, why is it still alive? So it's one of those things that the process of rebuilding or redoing everything or changing everything to, let's say, microservices, which I gladly people are also stepping away from because that also introduces a lot of problems. That's a separate discussion. So yeah, that can just take as much effort as it would have to really wrap up the maintenance of your long-lived app and tackle all the check debts. And I think, yeah, the third option of just migrating it is really interesting, especially if you look at, hey, we actually want to go to that language which has these features or has these kinds of developers. I think that's really relevant. So I'll actually keep that in mind. Thank you.
Yeah, sure.
Any more questions?
Yeah, I was curious from like in your organization about how much time is spent like actually writing code and how much time is spent doing everything surrounding that. So writing tests, writing documentation, writing.
Yeah, that's a good one. Off the top of my head, like I don't have the measurements. I would say maybe it's around 60-40, so 60% of the time writing code, 40% everything else. That's about what I would think. So ideally, you would love to write more code, but yeah, the whole process, that's just kind of the reality of working with a legacy app. There's also a lot of process to keep in mind.
With what you just told us, I think 60% is still quite high. I expected less. Yeah.
But what's for you? Or like, what do you think is like the distribution for you?
For me?
Yeah.
Yeah, I think maybe 50% writing code and 50% in, let's call it overhead.
Yeah.
Yeah, meetings, decision making.
Yeah, I think what we do is we try to concentrate, because we're a fully remote company, I'm not sure if I clarified that, but we work very async, and when we have a lot of meetings and discussions, we try to concentrate that on 1 or 2 days, so we can really go full focus, full steam ahead on the other days, because we've noticed if, let's say you have 2 meetings in a day, then your productivity as a developer drops significantly.
Yes.
Especially for remote workers, you know, being at home, you really want to go in there, and focus. And we also encourage people to either like set their icon of status on Slack to focus, or just block it in their agendas. Nobody will bother them, and really kind of make sure that you get the maximum productivity out of the times that you can develop. And I think that's why we maintain that balance, slightly more code than meetings.
Yeah, it's a good approach, and it's really good if the company is open to that. Yeah. Nice. All right. I don't think there are many more questions.
Yeah, and thank you all for the in-depth discussion as well. I think that's really useful.
Yeah. Thank you for the presentation. It was really insightful. Yeah. Liked it.
Awesome.
Yeah, thank you.
Yeah.